Since this is our first time with SAS On Demand, let's start from the very beginning. So we're going to go to your favorite browser and type in support.sas.com/ctx3/sodareg for SAS On Demand registration. I'm going to assume you already have an account because you were sent an email about that. Sign in with your email address, type in your password, sometimes it takes a little bit of time to come up with the internet. Now, notice your SAS server user ID is up here. Mine's Annmaria.demars. It is not the same as your email. So remember what that SAS server user ID is, because you're going to need it in just a little minute. Then here it'll show your course. It might be 611. This one happens to be 602. Click Run Client. Now you're going to sign in with that SAS server user ID. Remember, not your email. Password should be the same as the password for your SAS profile you signed in with. Now the SAS web editor is going to come up. So you're presented with a code window. You're going to type proc contents data equals sashelp.heart semicolon. SAS statements always end in a semicolon. Then run semicolon. Highlight that. Click on the little running guy, and it runs. Then you'll see that you have 5,209 observations in the data set, some other information about it, like 17 variables. Down here, you'll see the alphabetic list of variables, like age at death is numeric. Sometimes you'll have a label. Cholesterol status is characters, so it's probably like low, middle, high. So click on code up at the top to go back to your code window. Now we're going to write some more code, now that we know what our variable names are. We do a frequency step. Proc freq data equals, again, we're going to use the sashelp.heart dataset, which we have already loaded here, semicolon. Tables, we want a cross tabulation. We want a table of age at death by death cause. A slash, because there's an option we want, and that option is to create a data set. So out equals, I'm going to call it test1, semicolon. We'll create a data set named test1. Type run, another semicolon. We'll highlight that, run it. And now you see your frequency distribution. The number of people that died at 43, 44, 45. You can scroll up or down to see more of it. So we can see, for example, that one person at age 36 died of cancer, one died of cerebral vascular disease, nobody of any of the other causes. So click back here to go back to your code. We do a proc print data equals test1 semicolon run another semicolon. Normally you wouldn't necessarily print out the whole data set, but this is just for educational purposes. So proc print will print your data set. And you see that we have some people, in fact 3,218 of them, that have no cause of death and no age of death, probably because they didn't die. There's no percent for them. Those people are not included in the calculation. So we only have percents of the people who did die. So that's what's in our test1 data set. Age, death cause, and count, and percent. Now we're going to do proc gplot. Data equals test 1. We're going to use that data set we created, semicolon. Plot count, it's going to be our y variable, times age at death is the x-axis, equals death cause, semicolon. We'll get a separate plot for every cause of death. But we don't want every cause of death. We only want it where death cause is in a certain group. So death cause in, and in parentheses, we'll put the causes we want to keep. In quotes, cancer, comma, quotes again, cerebral vascular disease, end quote, comma, and quotes again, coronary heart disease. It has to be punctuated exactly like this because SAS is going to look at what's equal, and to a computer, cancer with a capital C and cancer with a lowercase c is not equal. It's not identical. You can make your window on the left smaller if you want to see more of what's in the code window. So, in parentheses, semicolon, where death cause in cancer, cerebral vascular disease, coronary heart disease. Now, just one more statement. Symbol 1. Interpol equals join, semicolon. That interpol stands for interpolation, and we want it to join all the plots together, so to make a line. And you can see this is what we get. So here's our first graph of age at death by cause of death that we did with SAS.